Good morning, students.
Good morning, sir.
आवाज आ रही है?
Yes, sir.
ओके का नहीं है? 5 मिनट वेट कर लेते हैं, सभी लोग ज्वाइन कर लेते हैं, उसके बाद स्टार्ट करेंगे क्लास। जो प्रेजेंट है अपना अटेंडेंस बना लीजिए एलएमएस पोर्टल पर। start the class. Just so we were discussing about the speed control of the induction. Control of the induction motor. That your topic, that topic we were discussing about how we can control the speed of an induction motor to your primary side, or you can say stator side, or you can say secondary side. So we have completed. So we have completed our stator part. Now we will discuss the rotor part. Okay. So let's start. So we have completed the stator part. That is the topic. Speed control from the stator part. The voltage upon frequency control, or we can say frequency control. That is for flux should be remain constant. The ratio of V upon F should be maintained constant. So the flux will remain constant. So if we vary the voltage as well as the frequency, if the variation is done through voltage, the frequency should also be varied. Then only the voltage, this ratio should be maintained constant. But if the only either of the term is varied, then the flux will change, and accordingly the your speed of the induction machine change. As you can see, this if you change the frequency, as you can see, this if you change the frequency is related with the synchronous speed, so accordingly the acting force increases. So as the frequency increases, the synchronous speed will increase, and the frequency decreases, the synchronous speed will decrease. This is the frequency control method. Then we have discussed the controlling supply voltage. That means this torque. We have discussed this torque equation. That is, this torque equation is related with this formula. That is directly proportional to C2 for R2. And now, when R2 is constant, if the rotor resistance is constant, in that case, the torque is related with the sparring of the rotor induced EMF. And as this rotor induced EMF is directly proportional to the voltage, that is how much voltage you are giving. If you are giving a higher voltage supply voltage, the induction will be the induction EMF will be higher. So in that way, this E2 is directly proportional to V. You can see that this E2 is directly proportional to V, and accordingly, this torque is directly proportional to the V square. So if you see that the torque is actually equal to the supply voltage, if we increase the value of the supply voltage, the torque will increase. If we decrease the supply voltage, the torque will be decreased. There is only one consideration should be taken place. That is, the variation of the voltage should be very much low, because if the variation is high, the torque, let us say let us say this voltage having the your 2% variation. That means torque will vary by 4%. Okay, as you can say, torque is actually equal to your V squaring term. So that concept we have completed in controlling supply voltage. Then there is a change in the number of stator poles. That concept is related with your this synchronous speed formula, that is n is equal to 120 F upon P. That is, if we change the number of stator poles, if we increase the value, the synchronous speed will decrease, and if we decrease the value, and synchronous speed will increase. That means both of these are inversely proportional to each other. Okay. Now there are other methods to control the speed by varying the number of stator poles. That we will discuss. That is not our discussion part, because that is not our syllabus. So just you have to remember those concepts related with your basic speed control method. Okay. And the next is your the pole amplitude that we discussed. Now there is another method for the stator part, that is adding a resistor in stator part, that is the many resistors are connected in series with the stator circuit, so that the starting current should not be much higher, because if we add the resistance, multiple resistors in the series of the stator circuit, then the current will flow. The current will very much less in the stator part, so that the winding of the machine will remain as it is. It does not work or broke down or puncture will be happened in your induction machine. So in that way, you can see that. But with the time, the stator resistance connected is cut out. As the speed should be increased up to a proper limit, so that the induction machine so operation very efficiently. So in that way, with the time, your value of the resistance is minimized for the setup part also. These are some methods that we were discussing in the setup part. Now the second part is your speed control from your rotor speed. Rotor, that means rotor side. And how if you have the value of rotated rotating machine, that means you have the control to rotor, so that the speed control should be done in the induction machine. So the first method is your adding external resistance on rotor side, that is adding external resistance on rotor side. Now external resistance in rotor side is related with this equation is also involves in this external resistance method, that is this torque equation that we have discussed in the previous part also, that is this torque is directly proportional to your S E2 square, then R2 divided by R2 square plus S extra square. Now, if we remove this concept is already discussed, that is, if we remove the proportionality constant, then you will get the constant value K, and that K value is having the value 3 upon 2 pi ns. That means indirectly you can say that torque is inversely proportional to its synchronous speed. If you provide the value of your K constant, proportionality constant. So it is written here, the three-phase induction motor operates in a low slip region. Low slip region means it have the value of, let us say, your induction machine. Wait a second. So in this method, the torque is also involved. That is, this torque is related with your sleep as well as the Q square R2. Now it is written the three-phase induction motor operates in low sleep region. That is the sleep having the value range is from 0 to 1. That means it is approximately 0.3, 0.4, or less than 0.5 will have the range of induction machine. So in low sleep region, that means the value of sleep is very much small as compared to the resistance. So this slip can be ignored. So it can be neglected, and also E2 is constant. In this case, if the E2 is maintained constant, so the torque equation is, you can see that E2 is remain constant, slip having the value very, very less value. Or you can say this is squaring method is squaring. If you square the very low value, you will get the let us say this is your 0.3. So if you square the value, it will reduce somewhat. A higher reduction will be there. So in that way, the total using the total concept, you will get the torque equation in this format, that is torque is actually C upon R2. So this, as you can say, we were dealing with the additional external resistance on rotor side. That means if you, this is your rotor part resistance. So if you again increase the rotor resistance, that means this rotor resistance, the rotor resistance part will increase. Rotor resistance, as the rotor resistance increases, the limit, the value of the torque will decrease, because these are two are in inversely proportional. So with the increment in your rotor resistance, the torque will decrease, but with the decrement in rotor resistance, the torque will increase. So it is written, if we increase the rotor resistance, R2 torque decreases, but to supply the same load, torque must remain constant. That means for the same value, the same load is given, and if you want to maintain the torque value, that means R2 must be remain constant, because this torque is inversely proportional to R2. As this remain constant, this will also remain constant, but this torque is directly proportional to sleep. So if we increase the sleep, we have to increase the as the torque increases. Okay, let us once again I am discussing this concept. This torque is directly proportional to sleep upon R. As the R2 increases, the torque will increase. But for the same load, if you want to maintain the value of the torque constant, that means you are increasing you are decreasing the value of resistance. The sleep should be increased, or vice versa. That means if we increase the rotor resistance for to maintain the torque, the the value of the sleep must decrease. Okay, so accordingly, the ratio of this torque related with the addition of the rotor circuit must be maintained at constant value. Okay, so adding of the addition of the additional resistance in the rotor circuit, we can decrease the value of the speed for your induction machine. That means the value of the slip should not be increased beyond some limit, because the motor operation should be taken place in the lower value, lower region of slip. So in that way, the rotor resistance must be increased, so that the torque will remain constant value. Okay. Now, what are the disadvantages related to this concept, or you can say this method? There are some disadvantages which is written in this point. That is, the speed above the normal value is not possible. First one. Second one is large speed change require a large value of resistance. Okay. If such large value of resistance is added in the circuit, it will cause large copper loss and hence reduction. That is fine. That is, if you increase the value of rotor resistance beyond a certain limit, then the voltage drop across the rotor resistance, that is I2 for R2, or you can say ohmic loss, or you can say armature loss, then the friction winding loss, as well as if the rotor resistance increase, the size of the machine should be increased, because the winding will be higher, or number of turns will be higher. In that way, there is a quite disadvantage regarding this method. Okay, regarding this method. So these are some. So this is the second part. Next one is your presence of resistance causes more losses. Okay, that we have discussed. Next, fourth point: this method cannot be used for squirrel cage induction motor. Okay, so these are the some 4 points related with this rotor resistance method. Okay, now the next one is cascade control method. Next one is a cascade control method. So cascade control method is quite large. We will discuss. So it is given in the let us discuss the theoretical part first, then we will move to the our discussion part. So of in this method of speed control, the three-phase induction, or you can say two three-phase induction motors are connected. Two three-phase induction motors are connected on a common shaft. Okay, hence called cascaded motor. That means coupling is there between two induction machine to the common shaft, or coupling is there between two common induction machines to a common shaft. One motor is called the main motor, and another motor is called auxiliary motor. Okay, the main motor, which one is called main motor? The motor which is taking the supply from the source, that is called main motor, and the motor that is connected with the main motor is called your auxiliary motor. So you can see here, the three-phase supply is given to the stator of the main motor, while the auxiliary motor is derived at a sleep frequency from the sleeping in the induction motor. Acha. Rotor frequency. Acha, let write a formula regarding the rotor frequency of the induction machine. Okay, just write it, the formula. No need to elaborate that. Rotor frequency equal to sleep into supply frequency. Just write the formula. if you have the copy or pen or some notes is given, the rotor frequency is equal to slip and supply frequency. That is the formula. If you have the numerical and say what is the rotor frequency of induction machine, just multiply the slip and the supply frequency. Normally, supply frequency, if it is given in the question, that is right, but if not given, take it as 50 hertz. So to find the slip, we have the formula. You know the formula. What is the value of slip? That is n rotor speed, synchronous speed minus your rotor speed divided by synchronous speed. That is the formula of your slip. Okay. So this is your connection of the two induction machine. One is main motor and another is your auxiliary motor. Next one is uh, how we can elaborate the concept here. So we see here, let ns1 with the synchronous speed of the main motor. This is the synchronous speed of the main motor. ns1 is the synchronous speed of the main motor. ns2 is the synchronous speed of the auxiliary motor. Okay, these are the nomenclature. P1 is the number of poles in the of the main motor. P2 is the number of poles in the auxiliary motor. F is the supply frequency that is given to the main motor. F1 is the frequency of the rotor induced of the main motor. That is this F1 that we have written here right now. You can say that this F1 is equal to slip into this supply frequency. This F1 equal to slip into supply frequency. So F1 is the frequency of rotor induced EMF of the main motor. Fine. N is the speed of set and it remains. N is the speed of set means N is the rotor speed. As you are moving the main motor, as you're moving the main motor to the supply source, that means you are there will be some rotor speed, and that rotor to the shaft is connected the auxiliary rotor part. So in that way, if you rotate the, let us say, main motor rotating at a speed of 1000 rpm, in that case the main and the auxiliary motor speed will remain same, or rotor speed will remain same, because the both are coupled together. Both are coupled together. So it is n is taken as the rotor speed for both the main motor and the auxiliary motor. Okay, fine. Now the next is how we can find the sleep of the main motor. As you know, the value of the sleep is your synchronous speed. That is the main motor of the synchronous speed is ns1. ns1 is given. Then the rotor speed is common. So ns1 minus n divided by, you will get ns1. So this F1 is the supply, F1 is the rotor frequency of the main motor. This F1 is given as this for the main motor. This is the sleep of the main motor and the frequency of the supply source. That is main motor supply frequency. Just from there you will get F1 equal to S1 into F. Now as the auxiliary motor is supplied with the same frequency as the main motor, that's why the frequency of the rotor part will remain same, because as you can say the common both motor is rotating with the common speed, that is n. So the frequency will be induced in the primary as the main motor as well as the auxiliary motor will remain same. That is F1 equal to n. Now it is written what is the synchronous speed of the secondary motor. As you have the frequency of the S2, F2 is given, so 120 F2 upon P2. P2 has the number of poles in the auxiliary motor. So from there you will get S2. In the similar manner, you just put the value of F1 equal to S1 into F. F2 equal to S1 into F, you will get this one. Then F1 equal to S1 into F, just put the value of S1 into F. Here S1 is the supply frequency, sleep of the main motor. This is the supply frequency. This is the number of poles in the auxiliary motor. So from there you will get the synchronous speed of the secondary motor. Now put the value of S1. Put the value of S1 here. S1 have the value this one, ns1 minus n divided by ns1. You will get ns2, that is synchronous speed in terms of synchronous speed of the auxiliary motor in terms of synchronous speed of the primary main motor. You will get this equation. Okay. Now at no load is written at no load, the speed of auxiliary motor is almost same as its synchronous speed. That is n equal to ns2. Fine. N equal to ns2. So the synchronous speed is ns2 is also written as rotor speed of the auxiliary motor, that is n. The ns2 is replaced with the n, and rest of the terms is as it is 120f ns1 minus n divided by p2 ns1. So this is the rotor speed of the auxiliary motor. Now rearrange the equation, you will get this one, n equal to 120f divided with P1 minus P2. Okay, that is ns1 minus n. You will get from there. You will get P1 minus P2. Just remember this formula. This is not the elaboration part. Okay. So by cascading the two motor, you have the rotor speed. This one, that is 120 f upon P1 minus P2. Acha, just try this equation. Just solve this equation and rearrange. What you will get, whether it is whether you are getting this equation or not. Tell me in the next class. So the cascading of the, as you can say, the rotor speed is related with 120 f upon P1 minus P2. From there, it is written, this cascaded set of two motors will now run at new speed having number of poles P1 plus P2. Okay, number of poles here it will be P1 plus P2. वही P1 minus P2 नहीं होगा यहाँ पे P1 plus P2. So this rotor speed is depending upon the number of poles of the main motor as well as the second auxiliary motor. As the number of poles increases, this rotor speed will decrease. That means if we increase the number of poles, your machine will have the less speed, and if you have the less number of poles, that the speed will decrease. Okay. Now in the above method, the torque produced by the main auxiliary motor will act in the same direction. Fine, because of the summation and rotation of the machine, the torque will remain in your clockwise direction. Now, such type of mechanism is called cumulative cascading. So, so up to this point, this is the main concept is up to this point. That means if you this one be P1 plus P2, and if we increase the total number of poles in the main as well as the auxiliary winding, the number of the speed of the rotor will increase if the decrement is done in the number of poles and vice versa. Right? These are some formula. If you want to take the, you don't have to take the screenshot of this one. Don't need this one. Now, next part, that the last part, that is last part of the speed control method of induction machine is here. Injecting slip frequency EMF into rotor side. That means if you inject slip frequency means that is the frequency related with the slip, that is rotor frequency, or you can say loss. That is, loss will be involved in this concept. That is your only loss will be involved in this. Okay. Okay. So accordingly, the slip frequency is given. The power slip power will also be there. That is, some part of the power will be there. So accordingly, if we inject the slip frequency EMF, full name is slip frequency EMF, into rotor side. Okay. Now what is this? What this method is all about? Let us discuss. So you can say that when the speed control of three-phase induction motor is done by adding resistance in rotor circuit, that we have discussed, the part that is rotation. If we increase the rotation, the torque will increase and vice versa. That is when the speed control of three-phase induction motor is done by adding resistance in rotor circuit. Some part of power called the slip power is lost as I explained. As we can see that if we increase the value of resistance, the loss will increase as the connection will be done in series part. So if we include the resistance in series, then the loss will increase, and as a result, sleep power will somewhat become less from the previous one. Therefore, the efficiency of the three-phase induction motor is reduced by this method. Okay, by this method of speed control that we have discussed in the rotor resistance part. This slip power loss can be recovered. Now, this slip power that is lost due to the adding of the rotor resistance, this can be recovered and supplied back to improve the overall efficiency. That means we can increase the efficiency, which is decreased due to the rotor resistance part of the three-phase induction motor. That is done by your slip power frequency scheme. Okay, you can see that the three-phase induction motor, and this scheme is covering the power is called slip power frequency scheme. Sleep power frequency scheme. And this is done by, how it can be done? This is done by connecting an external source of EMF of slip frequency to the rotor circuit. That means we have to add some other equipment with the rotor part so that it can enhance the slip of the machine, and in that way if the slip will increase, the torque will also increase. As the torque is as the torque value increases, the EMF or the operational power of the induction machine increases. Now you can see that the injected EMF can either oppose the rotary induced EMF or add the rotary. Either it can decrease or increase the value of the rotary induced EMF. As you are increasing the slip of the frequency, it will must increase the rotary induced EMF. Now, if it opposes the rotary induced EMF, the total rotor resistance increases and hence the speed will decrease. As the rotor resistance increases, the speed will decrease. And if the injected EMF adds, that means it increase the rotary EMF, then total decrease and hence speed increases. That means if we add the EMF to the rotor part, then your speed will or resistance will decrease, and as a result the speed will increase. So therefore, by injecting induced EMF in the rotor circuit, the speed can be easily controlled. The main advantage of this type of speed control of three-phase induction motor is that a wide range of speed control is possible whether it is above normal or below. So the main concept about this injecting slip frequency of EMF into rotor side is from here. You can see that. Up to this point. That this is done by just by including your external induced EMF, external EMF machine. That is, the injected EMF either can increase or decrease. If we increase the EMF, in that case the rotor resistance will decrease and the speed will increase. And if we decrease the EMF by external source, then it opposes the then it will increase the resistance part of the machine, and hence the your speed will decrease. So this is for any speed of the machine can be controlled, that is above normal, above normal speed, or at normal speed, or below normal speed. The normal speed is named as the machine when it is operational at a nominal range, or you can say it is working perfectly for its thing. So this is the portion that the speed control of an induction machine. If you have any question, you can ask me. Anybody? Any question? Okay, fine.
हेलो सर
हाँ करनी है, बोलो।
सर मेनली स्पीड मतलब पोल्स पे डिपेंड करता है ना
Mainly
जितने
speed
नंबर्स
poles,
ऑफ
हाँ,
पोल्स
mainly speed number of poles पर डिपेंड करता है।
अगर नंबर ऑफ पोल्स कम होंगे तो स्पीड ज्यादा होगी अगर
अलग अलग
ज्यादा होंगे
मेथड
तो
का
कम
अलग
होगी।
अलग कॉन्सेप्ट है। जैसे वोल्टेज इंड्यूस्ड ईएमएफ में क्या हो गया था, वोल्टेज सप्लाई वोल्टेज अगर इंक्रीज करोगे तो टॉर्क इंक्रीज होगा। सप्लाई वोल्टेज से टॉर्क डायरेक्टली प्रोपोर्शनल है। सप्लाई वोल्टेज का वेरिएशन, उसमें सप्लाई वोल्टेज ज्यादा वेरी नहीं कर सकता क्योंकि जो टॉर्क है वो वी स्क्वायर पे डिपेंड कर रहा था। तो वी स्क्वायर में अगर ज्यादा वोल्टेज वेरिएशन करोगे तो फिर टॉर्क का वेरिएशन काफी ज्यादा। मान लो अगर 5% का वोल्टेज वेरिएशन हो गया, पहले हम दे रहे थे 230 वोल्ट, उसके बाद हम दे रहे हैं 240 वोल्ट, 5 वोल्ट का वेरिएशन हो गया। तो 5 वोल्ट का वेरिएशन से क्या होगा कि तुम्हारा टॉर्क का 25% वेरिएशन आ जाएगा। तो वो इकोनॉमिकल कर सकते हैं या इफिशियंट कर सकते हैं, वो नहीं हो पाएगा। ठीक है, तो
Yes, sir.
depending upon the situation, you can vary the speed control from above the normal speed or below the normal। तो जैसा हमारा जरूरत रहेगा उस हिसाब से हम नंबर ऑफ पोल्स कभी वेरी कर सकते हैं, कभी सप्लाई वोल्टेज वेरी कर सकते हैं, कभी रियो स्टेट लगा के स्टेटर पार्ट में स्पीड कंट्रोल कर सकते हैं, कभी रियो स्टेट लगा के रोटर पार्ट में हम स्पीड कंट्रोल कर सकते हैं। ठीक है,
Okay, sir.
और किसी का कोई क्वेश्चन? आज ये थ्री फेज इंडक्शन मोटर कंप्लीट हो जाएगा, हो गया। नेक्स्ट क्लास आई थिंक नेक्स्ट वीक हम रहेंगे नहीं, तो नेक्स्ट वीक क्लास में भी पॉसिबल ना हो। एक आदर्श तो नेक्स्ट वीक तो क्लास नहीं होगा, उसके नेक्स्ट वीक आपका सिंगल पेज इंडक्शन मोटर स्टार्ट होगा। वो एक टॉपिक है, ज्यादा ज्यादा एक क्लास या 2 क्लास लगेगा सिंगल पेज इंडक्शन मोटर। उसका टाइप्स बहुत है सिंगल पेज का। So all of you must have given the attendance to see whether you have to go. Where is not there. Many students are not given attendance. Vivek is also Vivek. Are you there?
Yes, sir.
अपना attendance दे लो बाबू।
Yes, sir. There.
Because you are on board. Let's given attendance. Then reserve option mechanical completed. And then given an idea given. Yes, completed. And then all of you given attendance. Now you can leave the class. Ending the session. We will meet from 25. हाँ करेंगे, कुछ कहना है?
नो सर।